The world is warming, but it is not warming equally. A world map shows temperature anomaly colors with the Arctic glowing dark red and the tropics showing lighter orange tones. When scientists map how much different parts of the Earth have warmed compared to the pre-industrial average, the pattern is immediately striking. The warming is not uniform. It is not a blanket of equal heat spread across every latitude and every landscape. Some places are warming 2 times faster than the global average. Some places are warming 4 times faster. Some places near the Arctic Ocean are warming up to 7 times faster. And on April 29, 2026, 3 days ago, the Copernicus Climate Change Service published the European State of the Climate 2025 report. The conclusion was stark. Europe is the fastest warming continent on Earth, warming at more than twice the global average rate over the past 30 years, 0.56 degrees Celsius per decade. The global average is 0.27 degrees per decade. Europe is warming more than twice as fast as the world average, and only one region on Earth is warming faster than Europe, the Arctic. The same 1 degree of global average warming is being experienced as 2 degrees in Europe, as 3 degrees in parts of the Middle East, as 4 degrees across the Arctic. The geography of heat is not one story. It is many stories happening simultaneously in many different geographic environments. Today, Where on Earth explains why some places are warming so much faster than others, and what that unequal geography of heat means for the people who live there. Subscribe to Where on Earth and hit the bell. Now let us understand the fundamental geographic reason why warming is unequal. The geography of warming is determined by one primary physical process: how well a surface or region can cool itself when it absorbs heat. Wet, humid regions have a natural cooling mechanism. When a tropical forest receives heat, the moisture in the soil evaporates. That evaporation absorbs energy the same way sweat cools your skin. The evaporated water rises into the atmosphere, carries the heat away, and eventually falls as rain somewhere else. Wet regions cool themselves through evapotranspiration. They are self-regulating to some degree. Dry regions cannot do this. Desert landscapes have almost no soil moisture. When a desert absorbs solar radiation, there is no water to evaporate, no cooling mechanism. The heat goes directly into raising the surface temperature. Desert regions warm almost as fast as polar regions as a result, and they start from a much higher baseline temperature. The Arabian Peninsula already averages summer temperatures exceeding 40 degrees Celsius. With warming 3 times the global average by the end of this century, parts of the Arabian Peninsula could regularly exceed temperatures approaching the survivability limits for human outdoor activity. Now let us go through the specific geographic hotspots one by one, starting at the top of the world. The Arctic is warming 4 times faster than the global average. The detailed science of why was covered in our ice melting video, the albedo feedback loop. White ice reflects up to 90% of solar energy. Dark open ocean absorbs 94%. As ice melts, more dark ocean is exposed. More dark ocean absorbs more heat. The loop feeds itself. Near the Barents Sea between Norway and Russia, the warming rate reaches up to 7 times the global average. Temperatures in the Arctic have increased by 4 to 5 degrees Celsius in recent decades, a change that in any other region of the world would be considered catastrophic. In Svalbard, the Norwegian Arctic archipelago temperatures have risen so dramatically that scientists describe the ecosystem as fundamentally transformed. Species ranges are shifting northward. Animals that have never been seen in the high Arctic are arriving. Species that depended on sea ice for hunting and breeding are losing their habitat. The permafrost across Alaska, Siberia, and northern Canada is thawing. As we covered in our permafrost video, that thaw releases ancient carbon, creating a second feedback loop that accelerates warming further. The April 29, 2026 Copernicus report confirmed that within the Arctic, the region of Europe closest to the Arctic sub, Arctic Fennoscandia, including Norway, Sweden, Finland, and northern Russia, experienced its longest and most severe July heat wave on record in 2025. Temperatures within the Arctic Circle exceeded 30 degrees Celsius. Temperatures above 30 degrees Celsius within the Arctic Circle, a geographic fact that would have been considered impossible 50 years ago. Now let us go to Europe. Europe is the fastest warming continent on Earth according to the April 2026 Copernicus report, warming at 0.56 degrees Celsius per decade over the past 30 years, more than twice the global average. The geographic reason involves several factors. First, Europe sits adjacent to the warming Arctic. As the Arctic warms, the temperature gradient between the cold Arctic and the warmer mid-latitudes decreases. That temperature gradient drives the jet stream, the atmospheric current that steers weather patterns across Europe. A weaker gradient means a weaker jet stream. A weaker jet stream means more frequent blocking patterns where high-pressure systems sit over one area for extended periods. Blocking high-pressure patterns produce prolonged heat waves. Europe experienced its second most severe heat wave on record in 2025. Temperatures across southern and central Europe reached extreme levels for extended periods. Second, Europe's proximity to the Arctic means it benefits from reduced albedo as Arctic ice melts. More solar energy entering the high-latitude North Atlantic and Barents Sea means more heat available to warm European air masses. Third, Europe's geography of mountains and seas creates complex local amplification effects. The Alps are losing glaciers that reflect sunlight. Mediterranean seas are reaching record temperatures. The combination produces warming rates significantly above the global average. 95% of Europe experienced above-average annual temperatures in 2025. 5 of Europe's warmest years have all occurred since 2019. All 11 previous years were the 11 warmest years ever recorded globally. Now let us go to the Mediterranean. The Mediterranean basin is one of the most geographically distinctive climate systems on Earth. A large enclosed sea is surrounded by 3 continents. This geography creates a unique warming dynamic. The surrounding land is warming dramatically. Mediterranean coastlines show cities and agricultural land experiencing extreme heat and drought. The Mediterranean land surface is warming at 3 to 4 degrees Celsius in models for this century. The sea itself is warming more slowly at approximately 2 degrees. The difference between the land temperature and the sea temperature drives the winds that bring Mediterranean rainfall. As the gap between land temperature and sea temperature shrinks, those wind patterns weaken. The winter rainfall that European and North African farmers have depended on for thousands of years is declining. MIT climate researchers found that the Mediterranean is projected to see 40% less precipitation during its winter rainy season by the end of this century. 40%. The agricultural civilizations of southern Europe, North Africa, and the eastern Mediterranean face water stress unprecedented in human history. Olive groves that have produced harvests for centuries are failing. Wine regions in France, Spain, Italy, and Greece are shifting northward. Water reservoirs across Spain, Portugal, and Morocco are at historic lows. The Mediterranean is not just warming, it is drying. The geography of an enclosed sea surrounded by warming continents creates a drying mechanism that no other configuration on Earth generates in the same way. Now let us go to the Middle East and the Arabian Peninsula. The Arabian Peninsula already contains some of the hottest places on Earth. Satellite images show the Arabian Peninsula as a vast, bright expanse of desert from above. Research published in 2024 found that the Arabian Peninsula is currently warming at approximately 3 times the global average rate. That rate is on par with Arctic warming. Desert regions warm almost as fast as polar regions for the same fundamental reason, because there is no soil moisture to provide evaporative cooling. By 2100 under high-emission scenarios, parts of the Arabian Peninsula could warm by up to 9 degrees Celsius above pre-industrial levels. Parts of the region are already approaching what scientists call the wet bulb temperature threshold. Wet bulb temperature is a measure that combines heat and humidity. When wet bulb temperature exceeds approximately 35 degrees Celsius, the human body cannot cool itself through sweating. Even in the shade with unlimited water, a healthy adult cannot maintain safe core body temperature at that threshold. At wet bulb 35, the geography becomes physiologically uninhabitable for outdoor activity. Parts of the Persian Gulf Coast already reach wet bulb temperatures above 30 degrees Celsius in summer. Some readings in recent years have exceeded wet bulb 35 briefly. The geography of the Middle East, desert heat amplified by lack of evaporative cooling, is approaching the outer boundaries of outdoor human survivability in summer. The same region we covered in our Middle East geography video that has all the oil and no water is also one of the fastest warming places on Earth. Now let us go to Africa and the Sahel. The Sahel is a geographic band of semi-arid savanna stretching across Africa just south of the Sahara Desert. A map of Africa shows the Sahel region as a band running through Mauritania, Mali, Burkina Faso, Niger, Chad, Sudan, and Ethiopia. It has been one of the most ecologically productive regions in Africa, supporting millions of pastoralists and farmers. Lake Chad sits at the geographic heart of the Sahel. In 1963, Lake Chad covered approximately 25,000 square kilometers. Today, it covers approximately 2,500 square kilometers. It has lost 90% of its surface area in 60 years. A combination of reduced rainfall, population pressure, and land use change has caused one of the fastest lake contractions in history. The Sahara Desert is expanding southward. The semi-arid Sahel is being consumed by the advancing desert edge. This process, called desertification, has been accelerating as global temperatures rise and rainfall patterns shift. The communities that have farmed and grazed the Sahel for generations are being squeezed. The same geography of straight-line colonial borders we covered, Mali, Niger, Burkina Faso, is now overlaid with the geography of advancing desert. States with no geographic coherence are facing a rapidly deteriorating geographic environment. The conflict and displacement now happening in the Sahel is not only political, it is geographic. Resources that once sustained millions of people are disappearing. Now let us go to Central Asia. Central Asia, the vast interior of the Eurasian continent covering Kazakhstan, Uzbekistan, Tajikistan, Kyrgyzstan, and Turkmenistan, is one of the most geographically vulnerable regions to heat. It sits far from any ocean, with no moderating maritime influence reaching its interior. Continental climates have extreme seasonal swings, hot summers, and extremely cold winters. As global warming amplifies both extremes, the interior of Central Asia is seeing summer temperatures that are approaching the boundaries of what outdoor agriculture and livestock herding can sustain. The Aral Sea, once the fourth largest lake in the world, has almost completely disappeared. Soviet-era irrigation projects diverted the rivers feeding it. The combination of water diversion and warming created a geographic catastrophe. Where a lake the size of Ireland once sat there is now desert. The geography of freshwater access across Central Asia is deteriorating as glaciers in the Pamirs and Tian Shan ranges, which supply river systems across the region, retreat. Now let us connect all of this back to the geographic pattern. The geography of heat is the geography of geographic disadvantage. The Arctic warms fastest because ice loss removes its reflective cooling mechanism. Europe warms faster than other continents because of its proximity to the Arctic and complex blocking weather patterns. The Mediterranean dries because an enclosed sea surrounded by warming land loses the temperature differential that drives its rainfall. Desert regions warm almost as fast as the poles because the Amazon have no evaporative cooling mechanism. The Sahel desertifies because rainfall patterns driven by the same atmospheric circulation shifts that dry the Mediterranean are pushing the desert edge southward. Central Asia bakes because continental interior geography has no oceanic temperature buffer. The same 1 degree of global average warming is being amplified differently by the specific geography of each place, and the places being amplified most are almost always the places that are already most stressed. The driest places are getting drier, the hottest places are getting hotter. The most food-insecure regions are losing the rainfall that their agriculture depends on. The geography of heat is the geography of inequality. The countries that produce the least carbon are in many cases experiencing the most severe geographic consequences of the warming that other countries produced. The Sahel, the Arabian Peninsula, Central Asia, the Pacific Islands we covered in our Sinking Countries video. None of them drove the Industrial Revolution. All of them are on the front line of its consequences. The Copernicus report published 3 days ago confirmed Europe as the fastest warming continent. That is where most of the scientific monitoring infrastructure is concentrated, where the data is richest. But the geography of heat extends across every continent, measured with less precision in many regions, felt with more severity by the people who live there. The world is not warming equally. It is warming through geography, and the geography it is warming fastest is the geography most people know least about. Subscribe to Where on Earth for weekly geography that reveals the forces reshaping our planet. Hit the bell and drop your thoughts in the comments below. Because the world looks very different when you understand where the heat is landing hardest.